Mauro Giorcelli from ICHAR. ICHAR is the Italian Biochar Association. We are at stand G34, sorry. And I am here like a chairman for this section that is dedicated, of course, to biochar, of course, about the new horizons on the biochar. We have only two speakers here in presence today. One is my dear friend, Bart, of course, and the other one is Pierre Monker, okay? So we start immediately with the first presentation from Bart Thomsen from CARBOGANIC, that will talk about the possibility to use the biochar in composite materials. So, Bart, the stage is yours.
I use this one. Just go. How does this work? Is it okay? It's this one also. Yeah. Okay. Okay. Good afternoon, everybody. So, as Mauro explained, my name is Bart TAMBUYSER. I'm from the company CARBOGANIC, and I will tell you something more about utilization of biocarbon in polymer applications, or less fancy plastic applications. Maybe I need to tell us a bit more about the image that you're seeing there. What do these ends have to do with biocarbon? But these ends, they symbolize a bit what we are standing for. What I mean with that, you see these hands holding each other together. They are passing on messages to each other. They are passing on stuff. They are a whole day busy with transforming biomass, and yeah, we also consider them as, let's say, hardworking as we are. Now, why are we offering this solution to the market? On the one hand, you have the plastic industry, and the plastic industry is looking for defossilization solutions. They would like to lower their CO2 footprint. Of course, this is because of policy. Nonetheless, they need to act now. And one of the ways that you can do that is by replacing fossil polymers with bio-based polymers. You could do that, but we do it in another way. We do it by adding a functional additive. This is how we like to look at biocarbon. Now, a very important aspect in this context are supply chain guarantees. What I mean with that is you can have an interesting material, what biocarbon is. It can have interesting features. Of course, there's always the element of price, but even if you tick all these boxes and you cannot guarantee the supply chain in volume and in quality, unfortunately it will not happen. So this is something that we need to take care of. Now, why would biocarbon producers be interested in our solution? What we sense is that several biocarbon producers are looking for other outlets, other markets, markets that bring them higher added value, markets that are more stable, more continuous, less seasonal related. So this is the reason why the biocarbon, in fact, is interested in what we have to offer. Besides of that, plastics, it's a generalization. It can mean many applications, so there are many markets that you can go to, so you really can look at it as a very diversified market. And of course, last but not least, it's of course also about contributing to the environment. It's about lowering the CO2 footprint. It's also the case that this is evolution, that applications in thermoplastics are considered as carbon sink. Now, when you look at the image behind me, it's an example of a biocarbon. In this way, you cannot use it. There are still a lot of things that you need to do if you want to go to a thermoplastic application. So this is kind of technically challenging. We call it tailoring. You need to refine the biocarbon. Later on, I will tell a bit more what I mean with refining or tailoring, and what is really our know-how. It's in fact in the formulation. Even if you bring a biocarbon up to spec, so that it would be possible to go to a thermoplastic application, you still need to have the know-how to come up with the right formulations, using the right polymers, using the right additives in order to make that happen. So this is in fact what we are offering as CARBOGANIC. So our real know-how and IP is in the tailoring and the formulation of biocarbon. Just a bit more about CARBOGANIC. We think that we have an interesting group of people brought together. Myself, I have a background in biomass feedstocks. I am an agronomist that ended up in the field of plastics, of polymers. We have people on board that are specialized and that were even owning pyrolysis technology, and we have experts in polymer technology. Where are we based? We are based in Belgium, in the harbor of Antwerp, the second biggest petrochemical cluster in the world. We have our offices at Bluechem. It's an incubator for sustainable chemistry, because the petrochemical industry is making a transition to more sustainable materials with a lower CO2 footprint. What are we going to do this year? We are building our demo plant, and this demo plant should be operational by the end of the year. And what will we do on this demo plant? We will produce on industrial scale, sample size. You need to think of not of grams, but 100 kgs or a ton of material, so that an industrial player can really assess if he can use our material. I need to say something more about this terminology, BC2U. That's something that we came up with. Is biocarbon to utilization. Now, we like to see ourselves as a single point of contact, in the sense that a biocarbon producer, we need to help him, we need to assist him, first of all, to explain him how could we bring his biocarbon to the thermoplastic market. On the other hand, there is also the market, and we also need to assist them with developing the market, and also we need to support the thermoplastic industry. Now, there are some steps in the process. Of course, it starts with biomass. It goes through a pyrolysis process. I think by now it's clear that the feedstock at the base, the composition of it, will influence the biocarbon quality, the pyrolysis process, so circumstances, temperature, residence times, all these parameters have an influence on the type of biochar that you will produce. And then if you want to go to a thermoplastic application, there are some steps that you need to go through. First of all, we like to have the material as dry as possible. In an ideal world, you want 0% of humidity there. Of course, this is not so evident, so you need to have a technology that can also dry the material even further down to achieve as low as possible humidity contents. You need to calibrate the material. Most of the times we are talking about fine particle sizes, micron scale, and then you get something that is black, it's carbon rich, there is a potential of dust explosion. If you don't know what you are doing, there's also a risk of auto combustion, and for that reason you need to neutralize or stabilize the material. This is something that is very specific, and there are not many people walking around that really know what they are talking about. And in the back of the room, Jean-Christophe, maybe later on, or maybe you can, if you want, just come in front and show your face so that people know who you are. Jean-Christophe, he is a guy who is 20 years active in the pyrolysis field, and to my understanding, he was the only one who was doing what I'm describing there. So he's a strategical partner of us, and it's Jean-Christophe who is covering the aspect of micronization, calibration, and neutralization. Now the next step is you want to bring it into a form that the plastic industry is happy to work with, because we experienced it the hard way. A black, fine, dusty product, easy to handle. This is not what they are looking for. So we need to bring it to a form that they are happy to work with. That means we need to densify it. We need to bring it to a form that is compatible to the compounding process, and this is what we call, we turn it into a functional biocarbon master batch, and this is where our know-how comes in play. And then you get something that is nearly drop-in for the compounding industry. You will not get problems with dosing, bridging, and we also make sure, taking into account the end application of the customer, what functionalities, what characteristics is he looking for, this we already take into account in the master batch that we develop for them. I give a practical example of an application. So this is the market of large-scale 3D printing. So it's really to print large objects, boats, tiny houses, chairs, these kind of things. This is a field where historically ourselves, we went quite far in the process. We developed ourselves commercial grades, and we even have a patent on this application. So yeah, so how would the process work? How would we come to a collaboration with a biocarbon producer? First of all, we need to go through the different steps, and we need to understand the material and the process. I give you here an example, an image of how an agglomeration formulation installation looks like. So it's in this machine that we add the biocarbon powder, we add the polymers, we add specific additives, which gives you at the end of the day the functional master batch, which is easy to handle. It's the density is way higher. You need to think of, let's say, 700 up to maybe even 800 kilograms a cubic meter. As a result, you can also export it quite easily, instead of starting to export a biochar that has a low bulk density, in some cases is even made very wet. So these things we all tackle, and it's also way easier to pack and to store. Just an image of the demo plant that is under development, and what I'm going to mention also here, not because it's fancy or trendy, but the next thing that we will do is we will implement machine learning, so artificial intelligence in the demo plant. Why? Because the demo plant will generate unique data, unique master batch biocarbon polymer formulation data, and I believe strongly that this is the way to speed up the process and to even make the formulations better in order in time to have better materials and also to avoid a waste of material during production, because currently in a lot of thermoplastic processes it's still a lot of trial and error, and so and this is of course what we would like to avoid in the future. Here I give a few of the functionalities that you can express with a biocarbon, but it's not limited to this, and in fact these features you can influence with the biocarbon, with the particle size, and of course also within the formulations that we use. You can have other features depending on the end application. So here you have an image on an extrusion line. So this is how it would look at a compounder. And after the strand that is made, they make granules. So in fact, it's for this industry, the compounding industry, that we make these master batches. Yeah, this is an image of the 3D printing. So now, how would the process work? So first of all, we need to understand what are the goals, the wishes of a biocarbon producer. We also need to understand what feedstock is he using. What are the process parameters? Because as I explained, all these things, they will have an influence on the biocarbon. End of the day, they will have an influence on the market that you can go for with your type of biocarbon. After understanding the biocarbon that is being produced, we will create a formulation for a master batch. This master batch we will then test. We will test the mechanical properties, so we will prove indeed that this biocarbon is suitable for a specific market or application. So if everybody is still happy at that point, there is a go, no go decision that needs to be taken. What are we going to do? Does it stop here? Do you want to continue? Do you want to implement this? So then we need to do a feasibility study where we will explain the market potential, how the installation would look like, what will be the investment cost, the operational costs, all these things. And if this work is done, of course, there's another decision that needs to be made. Okay, we are really going to do this. We are really going to implement our technology. Then there is the phase of contracting. The contract agreement will cover engineering aspects, and it will also cover the commercial aspects. And we work via a licensing agreement. So people that want to use the formulation in order to come to a master batch, they will pay a royalty per ton of material that is being sold. And I also take the opportunity to present another strategical partner. So André, if you can come also to the stage, or he needs to catch a plane, and it was a hell of a trip for them to come here, so I don't want him to miss his plane. So just a little bit more about Ozon. Ozon is a Polish producer of biocarbon. They do this historically for the charcoal or the barbecue market. At some point, Ozon decided to change their business model because of the seasonality, the difficulties in selling the product. And they are, of course, also interested to see if there are better markets with a higher added value. So with Ozon, we signed a letter of intent where we agreed to do a feasibility study They are now currently producing 20 to 30,000 tons a year. They want to double their capacity. So for that reason, they are looking to diversify, and in an ideal world, not send their material to an energy application, but to a material application. So we agreed that we will do a feasibility study for 1,000-ton master batch capacity, output capacity for the first installation. So it's still, to be clear, a pilot project. So what is everybody getting out of this? At the end of the day, the biocarbon producers, thanks to the integration of our technology and our know-how, we hope to give them a continuous offtake of their material at higher added values. And as I mentioned, this is done via a licensing model. What is the thermoplastic industry getting out of it? The thermoplastic industry, they want to lower the CO2 footprint of their materials. And yeah, they are only going to do that if the supply chains are met, if it's a material that is easy to use, to handle. This is what we are offering thanks to the master batch. And yeah, as I mentioned, the guarantee on the supplies. So this is what I wanted to tell about CARBOGANIC and about our project and our ideas. I know it's been a long day. It's the second day, but if somebody still would like to talk to us, we have a booth here, H30. So yeah, you're welcome to have a talk with us. Thank you very much.
Thank you, Bart, for a very nice presentation about CARBOGANIC. There are some questions. If there are some questions, now we can...
Christopher Hayes from Ireland. I was talking to you yesterday, Bart, about 3D printing for us. A fantastic presentation. Thanks very much. I just had a quick question about, did you ever, guys, look into the recycling factor of that plastic when it has reached end of life?
Yes, of course, you're right. You cannot be blind to the end of life of the material. I need to be honest, our main focus at this stage was on material development. Nonetheless, we are not blind to it, and we already did testing on, like, for instance, materials that we were printing with. We grinded them again, we reprinted them, and I can tell you that, in fact, the biocarbon is a very stable material. It's thermostable, so it will not degrade if you will reuse it. And it goes even a step further, and this is already proof of concepts that we have done for recycled plastics, which are in some cases difficult to reuse. It's even so that the biocarbon can support the recycling of plastics. I cannot tell too much about it, but in fact it will even help to reuse plastics. So we've done it with PET, PP, polycarbonate, and the results are really interesting.
Thank you. Other questions for Bart? If there are no other questions, we go to the next speaker, which is Pierre MOCAER from TERRAWATT, that here in this presentation tell us something about TERRAWATT and the activities. So, Pierre, the floor is yours.
Thank you for the introduction. Can I have the... Okay. Hello, everyone. Thank you for being here. I'm Pierre-Yves MOCAER, Technical Director at TERRAWATT. And I'm happy today to present you the different projects we are developing here at TERRAWATT and the process also that we are developing that is coupling pyrolysis with biological methanation. I used to make a little introduction about carbon cycle, but as we are talking about it for 2 days now, I think I will skip it, and I will go directly to the next slide, which is this one with this question: how can we invert climate change? And here at TERRAWATT, we believe that there are at least 3 possibilities to invert climate change: by producing biochar in order to capture the carbon and CO2 in soils, but also by producing an organic amendment to increase the carbon stored in soil. In fact, we see that when we restore soils, we can store more carbon with the biomass in it, as you can see here in the here in this picture. When you have poor soils, you are storing really less amount of carbon, but as soon as you have restored soil, as like in forest here, you have more than 80 tons of carbon per hectare that can be stored. So we are working about that. And the third point is that we need to produce renewable fuels in order to substitute all the fossil fuels that are today in everyday life. So what about the TERRAWATT process? So we use biomass as an entrant. We can use biomass, as you can see here, as green waste from collectivities that are currently really poorly valued, that are composted. We also are using agricultural waste, that are non-fermentable, and that must be valued today, at least in France with the different regulation now. And we are studying different reservoirs, starting from 800 tons per year to 10,000 tons per year. And you can see here different photos that that I'm showing here that are sampling operation that we made on site in order to study the biomass with the CIRAD of Montpellier in order to see the capacities in pyrolysis. And so this biomass, we put it in pyrolysis kiln at high temperature. We are talking at about 750 degrees, 750 degrees. We are using a rotary kiln that you can see here, where you have biomass here and you have no contact of flames with the material. And this is producing syngas and biochar in controlled condition. The syngas is composed of H2CO, CO2, and you have also biochar that is produced here. But usually syngas is badly valued. It is burned or used for energy. And what we are doing here is that we are coupling a biological methanation process to value this syngas. So we are using methanogens microorganisms that can transform the syngas, the pyrolysis gases, into biomethane in bioreactor. So you have these few reactions, these few reactions here that are operating, in the bioreactor. You have the CO2 that reacts with the hydrogen to produce CH4 in water. You have also CO that react with hydrogen, and the CO that is reacting with water to produce CH4 and CO2. And so all this transformation occur in our bioreactors, and we can transform this clean syngas in biogas that have the same properties than the biogas produced in AD plant, with proportion of CH4 at 54% and CO2 at 45%. These pictures are photos from a pilot that we have here in Nantes, Titan 5, and this is working. This is working in co-current. You have liquid that is recirculating from top to down, and at the opposite, you have gases that are circulating from down to the top. And this will make a lot of interaction between liquid and gases, and with the bacteria will produce the biogas. Regarding the volume of this pilot, it is 10 cubic meters. Just a few words about the biochar, because we believe in its potential to restore the soil. We are working with different agronomic institutes, the CIRAD, l'INRA, DTU from the Denmark, which is the largest university in Europe, ELGO also in Greece, to work to characterize the biochar, to see its impact on soil, to the restoration of soil. And we strongly believe in it because it captures and fixes the micronutrients in soil, which will avoid the washout during rain events. It retains water also in agricultural soil, enhancing the soil resistance to drought. It helps the growth of microbial flora in soils, which will enhance the bioavailability of nutrients. And also the biochar will reduce acidity in soils, which allow restoration of fertility in degraded soil. So we strongly believe in these things that we also are studying with the Ergonomic Institute. Our team. So currently at TERRAWATT we are 5, with Yann Mercier and Eric Schugnol, who are the co-founder of TERRAWATT. Yann Mercier is the inventor and the developer of the process, and Eric Schugnol has more than 20 years of experience in economy and energy. Myself. There is also Marie-André and Franck Boucheron that were hired last year, so it's really new. Marie-André is a R&D manager, and Franck Boucheron is a plant manager. He is a plant manager and an operator on the site, on the project we have, that I will present after. Also, we have the support of Arthur Laken in external here, that he is working on carbon and biochar market. Regarding our story, we had several years of research and development. The startup was founded in 2014, and the 2 patents were published in 2016. We then had a few projects, a few experimental pilots. The first one with the INSA and the ADEME with a TRL of 3 and 4 that were finished in 2019. And then we had a new project with Leroux & Lotz and GRT Gaz, which is Titanfall, where we construct a small-scale industrial pilot. And these 2 experiences lead us to go to the next step, which is the industrial demo site and the go-to-market. So last year we got involved in 2 projects, in 2 European projects, Horizon project. The first one is SEMPREBIO, the second one is Phoenix. I will describe those 2 projects after. And then last year we got our first MOU signed, TRL4, and then this year we hope to go on commercial units and to develop this project on the full scale. So the first project we got last year, an Horizon project from Europe, is the SEMPREBIO project. We have 16 partners within this project with a global cost of 12 million. And the objective of this project is really to focus on the production of biomethane from green waste. You can see here we are really focusing on this part, so the pyrolysis of bio-waste or green waste, the biomethanation, and then the production of biomethane. So we are currently constructing a pre-industrial pilot on Marmagne site. It's near Bourges, at the center of the France. And we are using green waste from the city of Bourges, 800 tons per year, with a potential of 10,000 tons per year. So currently we are assembling the pyrolysis kiln. It will be delivered in the next months. And we are also designing the biomethanation reactor with a volume of around 200 cubic meters. The next project is more linked to the biochar. So the Phoenix project has the objective to produce a biofertilizer from green waste for soil recovery. Here we are with 9 partners with a global cost of 2.6 million. And this project is really, really interesting, I mean, for this session, because it's really focusing so on the production of biochar, as you can see here, and the transformation of it, the enhancement of it for agriculture. So here we are enhancing the biochar capabilities, the biochar coming from the last project. And the first step is to activate this biochar by a thermal treatment. So we'll modify the specific surface of the biochar from 5 meters square to 500 meters square per gram. So we'll have all these small pores that are coming here in the biochar. And this is done also with the help of the CIRAD and DTU. The second step to again enhance the biochar is to impregnate it with digestate from AD plant. And with this saturation of nutriment within the biochar, we will try to avoid the siphon effect when spreading on crops. The siphon effect is when you are putting biochar, and in the first months or years, you will have the biochar that will suck all the nutriments, and so will be a problem for cultures. And now we are trying to saturate the biochar with nutriments to avoid this siphon effect. What's important here in this project also is that we are working a lot on biochar. So we produce 36 different biochar with different conditions in pyrolysis and activation. So we'll have a large panel of biochar to test that we will mix or not with digestate, and then we will do some greenhouse study of the biofertilizing effect to measure the growth of plants in little pots. And then we will select the best mixture of biochar and digestate in order to make some trials on degraded crops within the Mediterranean perimeter. And we are talking here about crops in Spain, in Greece, and in France. So stay tuned, we have a website for these two projects. So if you want some news, the websites are updated every month, or there are news if you want to follow it. Regarding the development plan of TERRAWATT, I will go quickly on that. We are really in a major year, this 2024, because we are constructing our pilot plant and we are looking for new projects all around Europe or in France in order to develop our first commercial project. So the next year will be really important for us, and we also are looking for some fund to develop this project, so stay tuned also about that. This is my last slide, and I wanted to talk here about the incoming projects that we have, because we have also already some interest from different plants and different partners, sorry. And then we want to couple the TERRAWATT technology with AID plant following this schema. And what we want here is to really recreate the circularity in farms project or in agriculture. And what we want to do here is to construct a plant that is able to value the fermentable biomass with AID plant and also the non-fermentable biomass with the TERRAWATT technology. So here you will have all that is wood residues that can go here to high temperature pyrolysis and then biomethanation to produce biogas. You will have all the fermentable biomass that will go to AID plant. And what's important here regarding the circularity of the system is that the biochar produced here can be mixed with the digestate to produce a strong soil amendment. And also you will have biogas that is produced and then can be then used to be purified for grid injection, or that can also be used in vehicle after liquefaction. We also can upgrade this biogas in CH4 with H2 methanation. We are also talking with different institutes, with different academics to make protein production with this biogas. Or we can, at the end, use this biogas as heat energy or to produce power. So really the philosophy of TERRAWATT here is to work on circularity in the projects, in different projects, with collectivities and with all that is surrounding the plant and the project we are developing. Thank you for your attention. I will be pleased to answer your question if there are some.
Okay, there are some questions for Pierre. No questions, so maybe later. Now we have an additional speaker for us. So thank you so much, Pierre. So there is Marcel Huber, that everyone that work in biochar know very well. He's from Syncraft, and he is here to present something about Syncraft, I think so. Okay, the floor is yours, Marcel.
Thank you very much. As I missed the early speech on this event due to some flight issues that some of you have encountered as well, I have been invited to join this last session. I will tell you something about what we're doing, and this is also, of course, very much biochar related. Even in our case, biochar is not first, and I'm very sorry about that, but in our case, it's really about power and heat, and also, of course, biochar. My name is Marcel Huber. I'm one of the founders and CEO at Syncraft. And I will show you in the next 15-20 minutes some additional infos. We're pretty much doing not that different that we have heard before. I think, and I've heard that also in several speeches here, I think one message in front is that we have to go together in this big task when it comes to fighting climate change, and that biochar is a great solution. I think we all agree. But the thing is to make it affordable, to make it as a base product for industry, for plastics industry, for concrete industry. So it is really our call that biochar always comes by the usage of energy. And this is, I think, the core, the key, and our general mutual USP, that we not only draw down carbon or carbon dioxide, we also provide renewable energy. And that's what we are fighting for, to get this conveyed. We are in our 15th anniversary this year, together with PIREC, by the way. Funny things, almost the same story. Hello, Helmut. We are 50 people, 30 million. That is what makes me a small company based in Austria. And we're building what you have seen in the head slide, which is a 1 megawatt plant, which is our top-notch system. So what is the idea? The idea is not only to produce the biochar, but also heat, power, and biochar, and that in that range, we also produce more heat and power than biochar. So what makes us an energy provider? And what I really want to stress is, of course, that this is the mutual enemy. There is no interaction between us. It's just about getting rid of the CO2. And there's a very, very interesting special thing when it comes to bioenergy. And the big question, do we have enough biomass? That's one of the key questions. And the answer is very simple. Yes, of course. And it's not only saying, you can measure it. And you can measure it within the problem. Because this is this increase rate of the ppm measured in Hawaii since some time. And whenever you see it going up and especially going down, that is when it's summer or the northern hemisphere. And the northern hemisphere is land rich, tree rich. So whenever there's summer, the CO2 capture by the trees is bigger than our emission. That's the only way, a reasonable explanation. So of course, it will be a tough job to prevent all this biomass from rotting and turning into CO2. But if we can address a certain share of this biomass not rotting, then we are on a good way to do a carbon drawdown. And there's no better option to draw down carbon and to prevent biomass from rotting than turning it into carbon. And we have heard a lot from Hamed yesterday that there is no more stable element existing in the Earth's crust that can preserve CO2 more than biochar that is mature, that is on its inertinite state. Yeah, this is what nature can do. Nature can just does a very little long-term cycle of carbon drawdown, so it does it exactly the way we are doing it, but it takes a very long time to preserve some certain percentages of CO2. And the idea what we and the whole biochar industry is doing, we just accelerating this. Accelerating is by maybe 300 times than nature does it. And that is exactly the acceleration we need to do. When we talk about our power plants, I just want to give you a few numbers. We're doing them between 400 and 4,000 kilowatt power production. So it's not big one. We call that medium scale. Our power to heat ratio is very small, so 1 share of power ends up with 1.4 shares of heat. So we are very much focused on producing power and, of course, biochar. Yeah, what is critical is we have to be operated more or less 24/7, so you can't start and stop these plants every day. You have to have, let's say, 6,000 hours of operating hours on a full load to make these things worth doing. So this only makes sense if you apply them as a base load heat supply. This is crucial. Also, I think this is a very wise idea for all biochar plants because we not only produce the heat, we also produce a very valuable byproduct. But then you have a good offtake for the heat. This is the products we do. I do not want to go into details. So the top notch you see on the right side, it's the 1 megawatt plant, 1,000 square meters, 1,000 tons of biochar a year. These are the rough numbers, what we can do with the plant. It consumes roughly 6,000 tons of fuel, which is wood chips in our case. You see some references. This is the biggest one we have built in Switzerland during COVID. It's a 4 megawatt plant. You see one in Japan, one in Austria, and one in Croatia, which is self-supplying for wood industry. This is where we wanted to see our plants being built. And what is so special in how we do these things is the main purpose is to produce a clean gas and a clean carbon. And therefore we have decided almost 15 years ago to go with a very special process that is not doing everything in one go, but we have a stepwise approach. The stepwise approach has two aims. We have to get rid of the tar. Whenever you talk about pyrolysis or whatever, it's about these volatile things. Some call it nasty, me too. It's hard to deal with it, and it's a nightmare to clean it. So what we do is quite simple. We burn it. So there's no gas treatment in our system in terms of tar. We just burn it. Why? The reason is quite simple, because we need the energy anyway to generate the temperature level for charcoal gasification. And in fact, when you see here, we do pyrolysis first, and then we have here, we burn these nasty gases, and we have only 3 elements left. And it's CO2, water vapor, and carbon. And then the rest of the process is there to recombine a certain share of these 3 elements towards a syngas. It's not a pyrolysis gas, it's a syngas, which is very clean, very defined, and very suitable for modern gas engines. And this allows us to produce a condensate that looks like water and produce a blue flame just after getting rid of the biochar. So this is without any further gas cleaning. And there's another thing we are quite eagerly on is the fuel flexibility. Yeah? There's a big drawdown with us. We are wood only. So there's no agricultural waste we can use here. That has some reasons about the process temperature. It's above 800, 850 degrees. So if you have potassium, ash-rich things inside, they would melt. So we have to stay with wood. But in the terms of wood, we are very flexible. That means we can operate on bark containing different species. We can operate on fines. So this is a big advantage. But we have to stay with wood. We do that things quite industrial. We come with the top-notch engine suppliers. So for the small plants, 400 kilowatt, we go with 2G engines. For the bigger plants, we come with another Austrian supplier, which is Biochar, both 2 green engines, and the biggest single engine we supply is a 1 megawatt engine. When it comes to the fuel, why only wood? I explained it a bit further. We think that is the biggest, more or less homogeneous, globally available source of biomass. So you find it everywhere at the big volumes. And for this generation of big volumes of biochar, I think we need to rely also on wood. So also with the agricultural residues alone wouldn't be available to produce gigatons. What does our biochar look like? It's also quite special. It's quite mature. It has a carbon content of roughly about 90%. It's rich in powder. It's ash its ash is only driven by calcium or silicium, so there is no phosphate inside, for example, or only little shares of sulfur. So it's very clean, and that makes it, I would call the perfect raw material for material applications. We've heard a lot about plastics when we talk about concrete. These are our main focuses for our biochar, because all the power plants supply more or less the same biochar. So wherever you supply a single source of 1,000, 5,000 tons, it's quite comparable to the other plants, because they all run on wood. And that's a big advantage to supply from multi-sources, single off-takers that need big volumes. And this is something which we have tried to make our strength. What I also want to say is that most of our plants are up and running their carbon sink certification systems already. Together with the EBI, or as a baseload base hub for this development, we developed over several years together with other known biocarbon production manufacturers a quite sophisticated ecosystem for CDR trade. And you have then, within this ecosphere, you have those who really do the standardization of these units. You have these tracking frameworks, you have the standardization bodies. You have, of course, the legal framework, which will change in Europe with the CRCF regulation this year, hopefully. But then you have these retailers. And I really want to emphasize this, because every mature business needs its dealers and traders. Yeah? So the direct sales from producer to final consumer would make a necessity that I have a final product here. But this is something we will also want to stress. This is a raw material production. So you have to tailor it for the different applications at the customer side. And therefore you have to know where it goes for what purpose. And there's also one important thing I want to mention every time, is that not every biochar is the best one for each application. That's no magic stuff. It's just, it has to be built or born for a special purpose. But we're quite proud of that, that this system is up and running and gaining revenues for our customers. One of my last slides addresses inertinite. There has been a lot of discussions about the permanence. I hope it's solved now, because the 15 million gigatons of inertinite, which is equal to biochar in Earth's crust, they are here. We can't talk them or discuss them away, so they wouldn't be there if that wouldn't be the most stable element that we form. So this is the good news. And we are quite proud to make a biochar that is in average 4% reflectance, which makes it not a bad inertinite. Yeah. Very big call. Let's work together. Building such a plant means also integration. Customer relations, so you don't deliver an equipment, you install a holistic plant that needs a lot of boundary conditions. That's also our strength. We have built 37 units so far. Maybe that surprises you. Altogether, they produce more or less today 18,000 tons of biochar. Almost the same product, and yes, that's already in the kiloton range of removed CO2, which is not much when you think about the number of gigatons, but it's a beginning, and that's the call for let's work together on mitigating climate change. Thank you very much for your attention.
Thank you, Marcel, for the nice presentation. If there are some questions for Marcel, I think one.
Hello. Marcel, thank you very much. I really liked your strapline for this. The reverse is the new forward. I'm from 7Y Energy Agency in the UK in Wales, and we probably kicked off the Industrial Revolution by extracting in enormous quantities of the highest energy steam coal anywhere in the world. So we have a higher responsibility than many for trying to do something about the mess we created. I would like to very gently challenge your assumption about there being enough biomass. Certainly if we turn all the Northern Hemisphere's forests into plantation for producing feedstock for a variety of markets, that may well be the case. But we also have a responsibility to look after biodiversity and nature, so there must be some of that set aside, both in urban, peri-urban and rural areas. And we have also contaminated vast amounts of biomass potential feedstock with everything from heavy metals to PAHs to microplastics to forever chemicals. And I think when we are coming together as a biochar community to invest in facilities to create low carbon energy and a range of useful products, we also need to think about the opportunity to reverse some of this contamination. So I still think it's well worth looking at municipal organic wastes. It's well worth looking at leaf sweepings, at woody waste from the municipal waste stream, from agricultural residues, and things like sewage sludge as well, which have huge amounts of contamination, but which a very sophisticated separate stage process like yours could be adapted to deal with and produce a product which may be suitable for the construction industry, whereas it wouldn't be suitable for food-grade products. So I think we have a responsibility to try and do as much good and reverse as much into forward as we can when we are constructing facilities like this, and I'd like to know what you think about that.
I mean, that is, I just can 100% agree. There is no competition about this thing, because for us it's just that we have focused on what we call forest residues, because we're doing something a bit different. We have found our, let's call it niche. Maybe today it's a niche, but it has to scale like hell. But all the residues, maybe they are first to be considered. But I think from a biochar perspective, you have to really think about where you want to start from. Do you start from a raw material, which is wood? Or is your main purpose waste disposal, waste reclamation, or waste recycling or valorization? This is one of the key questions you have to address first before approaching such a project. And that defines what kind of technology you're going for and what options you have. That's, for example, I always compare with the biogas. There is no fuel competition between biogas and thermochemical utilization of biomass. And that includes gasification, pyrolysis, and incineration. Because the fuel for a biogas plant is different to that for the other. And the same is with waste. If you go for sewage sludge, it's maybe not a biochar, but it could be an awesome carbon-containing ash, but different purpose. You can't go maybe for plastics industry. I don't know. But it's really, we have to diversify, but be sure that we don't follow the wrong path. And getting a waste into a product in Europe can become a nightmare.
Sure, I agree. But it's also therefore important that we raise awareness amongst our potential customers that
Exactly.
there are a range of materials, a range of sources of materials, and a range of processes, and adopt a complementary approach.
Agree.
Okay, no other question for Marcel? Okay, thank you again, Marcel, if you want to sit there with us. Okay, and the last speaker for today is Tim Scholz, okay, from University of Kassel. Okay, thank you very much.
Thank you. Thank you very much. Our starting point is a little bit different from the technical providers. We are a European network trying to provide somehow or to pave the ground also for the practical people out there, for instance, for municipalities, for people who have really environmental problems or who want to get rid of their bio-waste. And I would like to introduce the whole thing because we were invited for the title Towards a Biochar-Based Circular Economy with a film about, with a little video about our approach as well. So can you play it, please? Thank you.
Annually, 37 million tons of residual biomass are wasted in Northwest Europe, which corresponds to a potential of about 2% of total CO2 emissions in Northwest Europe. The use and conversion of these waste biomasses into biochar is thus becoming an important strategy in the fight against climate change. In biochar, carbon can be stored for the long term. It can replace fossil coal and be processed into other products. This makes biochar the basic material of a circular carbon economy, which not only has a positive climate effect, but can also lead to sustainable economic and social development. However, the circular carbon economy is more than just a purely technical solution. It requires a well-thought-out, preferably local management concept in which 4 central elements and process steps are optimized and coordinated with each other. Biowaste is organic waste from private households, cities and municipalities, from gardening, forestry and agriculture, and residual biomass from nature conservation areas. This biowaste includes, among other things, green cuttings and hedge trimmings, roadside greenery, food scraps and residual wood. Biomass management here includes collection, transport, storage and pre-treatment of the biomass. Biomass is converted into biochar in pyrolysis furnaces in the absence of oxygen. This prevents the carbon from going into the air as CO2 and instead being stored in the coal. Pyrolysis produces thermal energy, pyrolysis gas and coal, which are used in the various plant systems in different quantities and qualities. The technological range begins with simple Contiki kilns, through small rural plants that fit well into local heating networks, and ends with high-tech carbonisation plants on an industrial scale, for example as components in urban waste treatment and sewage plants. Plant design and management are determined by the regional framework conditions, the availability of biomass input, the intended heat or coal production, and the targeted biochar quality. Biochar is the ideal feedstock for bioeconomy products and services. It has outstanding properties for water and nutrient binding and can be used in various industries. It is active in the filtration and purification of water and wastewater and can be used as a valuable soil substrate for gardening, agriculture and forestry. They are used as bedding in stables and for the reduction of odour nuisance in various industries, from medical technology to sanitation, and as an aggregate in the construction industry, clay plaster, concrete and asphalt. A sustainable carbon circular economy should be strategically planned. It makes sense to base this planning on necessary development scenarios. For example, climate neutral urban planning, sustainable water management, water storing and heat resistant cities. Promoting biodiversity, extensification of land and for sustainable agriculture. The circular carbon economy must link all 4 areas in a sustainable way and implement them locally, based on the available biomasses, optimal plant design and biochar qualities. Product and value chains for the regional bioeconomy are being developed. It offers opportunities not only for climate protection and economic value creation, but also for socially and participatively oriented regional development in Europe.
Does it work? Okay, so thank you for this one. First of all, I don't know, is it working? Ah, the wrong one? Ah, okay. So where is the back? Okay, so that was the end screen, actually. As you might have understood, we are working a lot with not the horizon, on the scientific part, but more on the question of how to bring it down to the ground and how to involve also, let's say, the local projects, the municipalities, and those people who would, in the end, also pay for pyrolysis plants. I can only agree with what Marcel said. There is no biochar fits all, but we really have to treat it as a complex system and select the right biomass sources, the right technology for the purpose, develop products in the end to build these regional scenarios as well. So let me just see. Okay, let's start with the biomass and tell a little bit the story that we started 15 years ago. Actually, we're coming from the middle of Germany. University of Kassel is placed there, and we are in a region which is described by these kind of landscapes. What we call the marginal grasslands and low mountain ranges in Germany. So you had this nice discussion about the available biomass, and this was actually what we have. We have a lot of biomass here because these low mountain ranges with marginal grasslands have a lot of biomass which is not used. And in the end, this leads to these pictures here, because they dump a lot of grass material that is not used. So we are really talking about residual biomass that we can somehow use, and that was our starting point, where we converted these bio-waste grass into something which had a wood chip quality in our first project. And just to give you an idea how big this region is, where we have these lands that are increasingly abundant because of the change in the agricultural production. This covers probably 25% of the whole area in Germany. Just to tell you, I agree, we have enough biomass, but it's kind of tricky to use it as well for biochar. But we have developed that over the last 15 years, also with pre-treatments and other things. Well, and this led in the end to our first project that we did in 2008, which was called ProGrass, which was a pre-treatment. And our idea was not to go for biochar, but just to use the materials from these abandoned landscapes in order to use them for energetic purposes. That was the first thing that we developed over the first 3 years. And from there, we went into riparian areas, which is, of course, quite interesting, because going back from the technical aspects of biochar, if you think about the floodings in Germany over the Christmas time, you see that the management of these riparian floodplains or river areas is a very important task, and we have to give the farmers some kind of income generating possibilities to extensify their areas, because this is one of the sources of the possibilities how to buffer the floods. The second idea was, of course, to use the domestic bio wastes, and the third one is, of course, the question of how to use roadside verges and the biomass generated there also for, and at that stage still, energetic uses, because you cannot simply burn it or something like that. You have to pre-treat that. And this was, again, the subject of two research projects that we did in Kassel at our place, and at a Central Europe project called Danube Energy, and in the end also something which brought us together with our French partner AILE here, the combined project which dealt with roadside verges. So that's what we did in the second stage. In the third stage, we went into biochar, because we had reached our limits for energetic utilization of these biomasses because of simple legal aspects, legal and economic, because this material was still treated as waste. And as waste, you can achieve, let's say, third of the price for other materials for energetic purposes. So we turned into biochar, and well, this was the next project called Redirect, and there we used, well, we could get funding for an investment at the sewage water plant in Baden-Baden, which is one of our strategic partners. It's a Pyrex plant that was installed in 2017, if I'm not wrong, but anyway, at that time, it's still there. And we developed our experiences with biochar production here as well. Next project, it was followed with the question, what are we going to do with the biochar? And I can only agree, we should really concentrate on the biomass inputs and have a very kind of stable production of a certain kind of biochar. Our approach was a little bit different, to think about what kind of products we can produce, and we created incubators in the frame of the project 3C. So actually, what we are providing, what we are still providing, are possibilities for young startups and small and medium enterprises to turn this biochar as a feedstock to develop products out of it. And within the 3C projects, we had a long range or wide range of different biochar products, ranging from biochar cheese to biochar concrete, of course. We have municipal partners who use it also as in asphalt and in other applications. So our approach is simply to try it out and to connect it to the, let's say, decision makers in municipalities and administrations, to bring it really into the practice as well. So that's our mission here, and all the photographs you can see, they are taken from our sub-projects here. And the idea of 3C was really to identify products and services related to the biochar production, which does not only mean that we have that in the technical sphere, but also maybe in the recovery, in the ecological recovery of protected grasslands, for instance. So another example is concrete, and I think you heard about that in the last days. We are also doing this. We use biochar addings in public furnitures, but also in designer lamps. So we have a strategic collaboration with a designer firm in Berlin that are putting biochar in their lamps. It's quite interesting, because it helps us also to make this, to bring this biochar into the public. So clay plastering is another thing, and this is quite interesting. So what we get as experience within our projects, it is rather simple to do this all on lab scale, and in research projects and all that. But if you have to convince your plumber to install something, it's a completely different story. Or your mason, or your whatever craftsman you have, because these people say, okay, we have other things to do. So what is their motivation? So our idea is to create kind of learning labs and tech centers to convince these people. So that's what we do, and that's the idea. And if we scale it up, we come to the term of bioeconomy, and that's what we mean with it. So if we put biochar applications, all kinds of different applications that increase permeability, we have to introduce also the craftsmen, the people that are really working on the basis, and that's what we want to do, be it for permeable cities, be it for things like greenings on rooftops or other things. And well, that's actually what we mean when we are towards the biochar-based circular economy. And for this purpose, we have founded a network. We call it 3C network because it's somehow the logical succession of the 3C project, European Network for Circular Carbon Economy. And it's consisting of 3 parts. It's still the hubs, the labs, and the net. And in the hubs, we develop, or we provide services for startups and small and medium enterprises to develop and to exhibit their products also on a very low level. That's what, and we supply support for them. Well, I've shown already the products and services that have been developed. Well, the second one is something which we can supply with our university partners. This is a kind of lab recommender system. This is going to the question that was somehow tackled by Marcel as well, to find the right biochar for the right purpose. It's a super complex system, and what we are providing is recommendation to find exactly what you use when you have a certain amount of biomass of a certain type, and you process it on. So what kind of use you can provide here. And well, the third one is the 3C net function. So we have a strategic collaboration with Biochar Zero that is simply to find the right producer for the right purpose as well. They are providing this sophisticated map because still, if you're a municipality and you look for biochar, it's not so easy to find it, and to find it for the right price, and to find it also, once again, for the right purpose with the right quality. And this is something that they provide as consultation services. And then we have a network of biochar experts. I hope that this is going to be a growing network, because, as you said, there is enough space for everybody at the moment, and the problem is global, and there is not. We should not go in terms of competition, but in terms of collaboration, and that's the idea, that this is becoming a growing network where people find their services and they're the right experts for the right purpose as well. And yeah, eventually, these are our partners at the moment. We're having 3 universities working together, several energy agencies, and certain municipalities working together. This is on a friendly, trustful basis, and we hope that we are going to extend the network as well. And the service that we render are highlighted there. So if you have questions, if you want to contact us, just give us a call. We are happy to work together with you. Thank you very much.
Thank you, Tim, for the presentation. There are some questions for Tim. No questions? Okay, so thank you. One question. Stop. The mic. Yeah.
Thank you.
Thank you for the presentation. I really enjoyed the video in the beginning. Is it possible to take?
It was expensive enough, I tell you.
So it's not to be spread to others. Okay. Would it be possible
what
to?
do you mean?
Do you have that video on YouTube or?
Yeah, we have it.
Yeah.
So just visit our website, you will find it there. We also have other very good videos, so you can also use them because we are funded by European Commission and they are open educational resources if you want. So you're warmly welcome to use them, mainstream them. Please name us. Good practice. Please do it.
Thank you.
Very happy to do that.
Thanks, Tim, for the presentation. I just wonder why the main partner network is not in Germany or Austria. That's it all only little number of spots and a lot of them in the Netherlands and so on.
Yeah, this network map is still an infant stage. I think we have approximately 90 contacts now, and the story is like that. I told you that we also had a Central Europe project, which was Danube Energy, and that was our only funded network in Central Europe. That was 2014 or something. And then we had the pleasure to work with Interact Northwest Europe, and this determines somehow the Northwestern focus. But we are very keen on working together to continue and to restart in Central Europe. And it's absolutely open. So this is the first, let's say, apart from a small intervention in Luxembourg we had, so 1 month ago. So this is the first publication for the whole thing, and we really want to go European, absolutely without limits. And if you are interested to join in, we would be extremely happy.
Just as one of the board members of EBI, I think it's quite crucial to spread the network and not to find senseless barriers and due to some inter-regulations and so on, because it's a European task. Yeah? Thanks.
But to my defense, the final project report was issued on the 31st of December. So that's really very fresh. So no, we will go for it. Absolutely. So thank you.
Okay. Thank you again to Tim. Okay. I think that we have finished our session. And so thank you to all to be here for this session. Thank you.
And then I tag you on.
But you have to be quick with audience.
Okay.
Not audience.
Oh, yeah.
Don't hide.
Okay. I will call you Mr. Selfie.
Okay, for sure, for communication. Thank you again.
Okay, hallo. Freut mich sehr. Ja.
In Deutschland so viele weiße Punkte haben oder so viele weiße Flächen.
Ja, na klar. Also ich meine das auch ernst, das war jetzt nicht irgendwie Show oder so. Nein, es ist wirklich gut. Nein, na klar.
Ob sie genau dort ein cooles Netzwerk, wo wir beim EBI eigentlich nicht haben.
Ja, das ist genau die Idee. Das haben wir. Ja, absolut.
Link, how are you?
Ah, good. Good.
Hello, Marcel. Marcel.
Ja, also.
I know Marcel. But it was a long time.
Nein, also
How you progress?
auch gerade, ich würde verdammt gerne in Richtung weil ich auch jetzt mal ganz konkret, weil ich würde gerne mein Vision-Projekt. Das ist eigentlich mein Job, das habe ich schon in Kassel gemacht. Ich habe ein Unternehmen gegründet, bin seit 15 Jahren dabei und wirklich die Story kommt aus der Ecke. Weil es ein bisschen unfällig aber wir würden wirklich gerne weitermachen. Wir schreiben gerade ein neues Interreg auf Wassermanagement mit Biochar und so weiter und so fort. Interessant ist jetzt aber wirklich. Ja, ja. Bei uns, oh Gott, ich meine, was abgesoffen in der norddeutschen Familie. Ja, und 2 Jahre zuvor konnten wir uns im Rasen. Ja, natürlich. So, und jetzt geht es genau darum, solche regionalen Szenarien zu machen. Und wir haben ein echtes Problem, weil wir haben ein Problem, dass wir es schaffen, Gemüseanlagen zu bauen. So, und wir sind, das sehen wir als... Ja. Nee, aber das ist genau unser Job. Das ist ja das, was wir vorhaben. Und deshalb haben wir ein neues Cascade, um genau regionale Szenarien aufzubauen und die regionalen Entscheider zu überzeugen. Jetzt lassen wir mal die ganzen Quatsch mit den Genehmigungsverfahren weg. Wir sind Uni, wir können sowas auch forschen. Blöderweise dort war Bart überhaupt nicht, weil das war Pionier, Bernhard Schäfer, gerne weitergearbeitet, aber dann ist es halt in der regionalen Politik auch blöd, aber der arbeitet jetzt bei uns. Und
alors les diapos, c'est comment ça se passe? Ça fait venir les gens. Ouais.
Alle Veranstaltungen Spaß reinzubringen. Deshalb passt das total gut, was wir eben gesagt haben. Das Networking ist da absolut dabei. Und ich meine, das ist das mit stärker zusammenarbeiten. Wir haben jetzt mit dem Fachverband Glaskohle zusammen.
Oui, il est avec nous. Ouais.
Also ich weiß gar nicht, wo ich jetzt angefangen habe. Machen ihr eigenes Ding, aber da
C'est le risque de la clôture. C'est dommage, mais tant de travail pour si peu de... Ouais, mais non, comme tu veux, tu peux te mettre au milieu.
C'est la clé? Oui, c'est moi qui ai la clé. Désolée, je vous l'emprunte.
Pas de soucis.
Merci, je suis prête.
Moi, je me mets là. Je sais pas dans quel endroit. Non, c'est toi d'abord, non? Ouais. Allez, vas-y. Eh bien, une clôture qui va être... On va essayer de la faire assez vite, vu que c'est dur de mobiliser du monde à cet horaire. Bon, on avait quand même envie, on trouvait que le salon, c'était vraiment l'endroit où on peut représenter ce qui a été fait et ce qui reste à faire ensemble. Donc on a réuni, on aura Hervé Denis qui nous... Je vais mettre la slide après. Donc Hervé Denis qui nous fera un retour sur les assises qui ont eu lieu en mars 2023. Gaël Canvet du RISPO qui nous fera un retour sur la journée technique Sol et Planète qui a eu lieu en décembre de l'année dernière. Et donc Shuruk Neitsaidi du club pyrogazéfication de l'AT2E qui nous présentera en fait le groupe de travail Biochar en 2024. Et donc je démarre direct par un petit rappel en fait de l'histoire de comment c'est parti et comment nous à AILE on l'a appréhendé. Donc à AILE, on est une association bretonne de l'énergie et on développe le bois énergie et la méthanisation sur la Bretagne et les Pays de Loire. Et la question, c'était un petit peu au départ, quelle place peut avoir le biochar entre ces deux filières-là à la ferme? Bon, je passe l'origine de AILE, c'est pas le sujet. Donc on avait fait l'année dernière au Bio 360, on avait fait une conférence, le biochar cherche sa place. Et là, c'était un petit clin d'œil, donc je voulais rappeler ça. Donc on a des choses qui ne tournent pas tout à fait comme il faudrait. C'est un peu le constat. Donc voilà, moi j'essaye de reprendre ça. En tout cas, c'est mon leitmotiv sur le biochar depuis le départ. Et essayer de trouver des synergies entre ces deux filières. il y a des besoins d'un côté, il y a des besoins d'optimiser, il y a des besoins d'autonomie. Et puis la filière bioénergie, en tout cas en Bretagne, elle est un peu plus mature, en tout cas sur la partie appro. Et il y a une norme biocombustible que nous on utilise aussi pour caractériser donc la biomasse ligneuse entrante. Et donc qui peut servir dans une filière biochar. Il y a des initiatives aussi de valorisation des coproduits dans cette filière-là et j'ai envie de dire des innovations sur des portages de projets innovants. Et il y a besoin de rapprocher les cibles de la ressource. Donc tout ça, ça peut s'embriquer dans ce sujet biochar pour essayer de faire que ça prenne, parce que ça prenne à la ferme, c'est bien, et si ça peut prendre sur les territoires, et en cohérence avec les territoires, eh ben c'est mieux. Donc je fais un petit clin d'œil, c'est qu'autrefois, le salon, c'était aussi les carrefours de l'eau. Alors les carrefours de l'eau, ils seront la semaine prochaine. Autrefois, c'était réunis, et je trouvais ça pas mal aussi pour le biochar. En tout cas, les acteurs de l'eau, ils vont être incontournables, donc il faudra qu'on s'adresse aussi à eux, et pas que, les acteurs de l'air. Et puis il faut qu'on ait en tête quand même ces 4 mots-clés, quoi: sol, alimentation, eau et air. Alors là, c'est un petit peu compliqué pour l'heure qu'il est. Je vais le passer très vite. C'est d'essayer d'illustrer ce que je vous ai montré en fait sur une ferme où on pourrait imaginer quelqu'un qui veut de l'autonomie, enfin tout ce qu'on se dit, qui veut relever des défis en termes de gestion de pollution et autres. Et le biochar pourrait trouver une place là-dedans. Donc, ce qui a été un peu illustré par Tim juste avant et qui là peut-être est un peu plus concret. Bon, j'avance vite, je ne vais pas le présenter parce que je pense que c'est un petit peu lourd. Mais j'aime bien quand même parce que ça illustre et surtout deux façons de voir des médias filtrants faits avec des ligneux peut-être et des substrats plus biodégradables qui pourraient être faits, ce que nous a montré Tim tout à l'heure, des fauches d'herbes de milieux naturels ou avec des enjeux aussi environnementaux derrière. Alors qu'est-ce qu'on a fait depuis 2016 ? On a essayé de faire passer des messages autour des usages, autour des intrants, sur la durabilité des filières. Caractériser les biochars, on a émis l'idée il y a longtemps, mais ça c'est très compliqué à mettre en place et ça on n'a pas les moyens aujourd'hui spécifiques pour le faire. Mais en tout cas les 3 messages, c'est la multifonctionnalité, la qualité gage de valeur ajoutée et l'approche territoriale. Sauf qu'à un moment, nous, à AILE, on est court. On est court sur ce sujet parce qu'il y a tout le côté utilisateur et il y a tout ce côté recherche. Et ça, nous, on ne sait pas faire tout seul. Et quoi de mieux que de s'associer avec les acteurs dédiés à ça, la force des réseaux. Donc, on a embarqué avec nous B2E et Unilassal pour essayer d'aller un peu plus loin ensemble. Alors, là, c'est l'histoire du GT. C'est là que démarre la réunion des acteurs, l'éclairage de ce sujet. Hervé, t'en étais le copilote avec mon collègue Marc Letrace, qui n'est pas présent aujourd'hui et qui n'a pas chômé pendant ce programme, en tout cas SRICI, là, 2019-2023. Il ne peut pas être présent aujourd'hui, mais voilà, je lui passe un petit mot doux. Et je te laisse, Hervé, peut-être quand même, le GT, c'est...
Oui, bonjour, donc Hervé Denis, là, président de Bretagne Eco-Entreprises pour le régional transition énergétique et environnementale en Bretagne. Juste pour remercier, effectivement, c'est celui-ci, je crois. Ah tiens, vas-y, si tu peux. Ouais, si tu peux zoomer. Juste en quelques mots pour déjà remercier mes partenaires, nos partenaires historiques, comme l'a dit Jacques, c'est l'association AILE qui est venue nous chercher pour ce programme Tricy sur le biochar. Et nous, avec la composante de pôle régional, on avait toutes ces thématiques dont tu as parlé tout à l'heure. Tu as parlé de l'eau, de l'énergie, tu as parlé de l'air, du bruit, mais des thématiques, le sol, l'agriculture, qui nous paraissaient... Cette thématique du biochar nous est apparue évidente par rapport à cet aspect de transversalité. Et donc, on a accepté de collaborer avec vous. Et donc, on a créé, effectivement, d'abord, on a collaboré ensemble sur ce programme Tricy, ce programme européen sur le biochar, avec d'autres partenaires européens. Vous avez vu Tim tout à l'heure, donc qui en a parlé. Et puis, on a travaillé après sur notre partie territoire breton. Et on a souhaité, je ne sais pas si je peux enchaîner avec les assises maintenant ou pas. On va le faire un peu... Ce qui s'est passé, c'est que dans la réflexion au travers du biochar, qui était une réflexion groupe thématique breton, entre guillemets, élargie à la Loire-Atlantique aussi, on s'est rendu compte très rapidement qu'il y avait un engouement national et international, puisque au travers de ce groupe thématique qui a été monté sur les biochars, on s'est rendu compte qu'il y avait vraiment un engouement sur... une demande de maîtres d'ouvrage, une demande des producteurs de biochar aussi, de montrer leur savoir-faire, de montrer leur existence, et puis aussi l'ADEME qui nous a sollicité un échange partagé, qui nous a demandé de savoir où on en était réellement sur le biochar, parce qu'on en entendait de tout, les biochars, quel biochar, quel type de biochar, est-ce qu'il y a vraiment un marché, est-ce qu'il y a vraiment des acteurs, une demande, etc., etc. Et donc de là est venu ces fameuses premières assises du biochar qui ont été organisées en 2023 à Rennes et qui ont eu un fort engouement. Avec, vous avez le programme qui est présenté, plus voilà, on avait 150, à peu près 150 participants. Comme je vous l'ai dit, producteurs, consommateurs, des maîtres d'ouvrage qui se posaient la question de savoir est-ce qu'il y a un business, pas de business, est-ce qu'il y a quelque chose. Et donc l'idée de ces premières assises a été d'être transparent par rapport à un marché, par rapport à un produit, un biochar, qu'est-ce qu'il apporte réellement, qui le produit, est-ce qu'il y en a déjà sur le territoire, qui en a besoin. On parlait tout à l'heure des acteurs de l'eau. Par exemple, chez B2E, vous avez des acteurs comme la SOR, mais pas que, des exploitants qui utilisent ce charbon, ce charbon végétal pour le traitement et qui vont le chercher très très loin, sans trahir de secret, et en se disant mais pourquoi on ne le produirait pas sur le territoire français, entre autres. Donc voilà, c'est cette réflexion-là qui est intervenue. Vous avez quelques éléments que vous allez retrouver, je pense, pour ceux qui sont présents et qui ont envie de récupérer. Je vais pas rentrer dans tous ces chiffres-là. Je vais juste dire l'important aujourd'hui pour nous, la dimension régionale B2E, l'association AILE, l'école des métiers de l'environnement, qui est l'université qui nous a accompagnés sur l'analyse des biochars. On a souhaité, après discussion, la transférer à la T2E, qui pour nous représente le niveau national, le niveau au-dessus, et donc avec le club Pyro, tu pourras en parler tout à l'heure, hein, Chourouk. Et donc c'est avec plaisir qu'on transmet ce flambeau, et on y participera, on y contribuera à votre demande. Donc je voulais vous dire que les travaux ne s'arrêtent pas là, le biochar continue. Voilà, Chourouk, ce que je voulais te dire, et très heureux aujourd'hui. Je sors du texte, mais c'est pas très grave. J'avais envie de le faire comme ça aujourd'hui. Voilà. Et donc pour vous dire que si vous avez de la biblio, si vous avez des informations, il y a tout un travail de fond qui a été fait par ces trois organismes qui pendant 3 ans, qui ont travaillé sur le sujet, France International. Bien sûr, la T2E va récupérer ça, mais si vous avez besoin d'informations à votre disposition, Bretagne Eco-Entreprises, l'association AILE et l'école des métiers de l'environnement pour vous transmettre des éléments. Voilà. Et je suis désolé, je dois m'absenter, je dois retourner à une autre conférence.
Merci beaucoup Hervé d'être venu. Il doit partir, donc merci. À bientôt. Voilà, donc avant de parler donc, du GT en 2024, on voulait vous faire un petit retour sur une journée qui s'est faite donc, en décembre 2023 en présentiel. Donc Gaël, je te laisse.
Merci. Donc Gaël Canevette du RISPO, à la demande de l'AT et de L, je vais vous présenter une journée qui a eu lieu en décembre dernier à Paris, en présentiel donc, sur le biochar. Alors cette journée elle a été organisée avec le concours de l'AT Club Pyrogazéification par le RISPO, parce qu'en fait, ouais, rapidement. Ah non, le verre là. Ah, le gros verre, d'accord. Donc le RISPO, très rapidement, c'est une centaine d'adhérents en France. C'est des exploitants ou des experts de l'organique. Et donc l'intérêt pour le RISPO, qui fait des actions de promotion de la filière, qui défend la filière aussi en lien avec Amorce. Et alors l'arrière, bon. Donc l'intérêt pour le RISPO de faire cette journée, c'était un point de vue organique sur le biochar, c'est bien, tout le monde en parle au niveau national, international, mais en fait il y avait une envie de savoir qu'est-ce que ça faisait dans le sol, dans le biochar, est-ce que c'est si merveilleux que ça dans le sol. Donc on avait invité beaucoup de chercheurs, on avait invité des gens, Monsieur Hélène qui est présent, pour avoir un panorama vraiment pour des néophytes. Là, je suis un peu, je suis un peu la mouche du coche dans cette présentation. En fait, on était tous très néophytes sur le biochar, à quoi ça peut servir, et surtout, est-ce que sur le sol, ça va avoir un intérêt ? Avec donc de la réglementation et puis des retours sur les dernières recherches menées par le Ritmo pour l'ADEME, menées par Unilassal. Et puis on avait la chance d'avoir deux producteurs de biochar, Fertilis et Carbon Loop. Carbon Loop qui est intervenu aussi hier, je crois. Donc voilà.
Producteurs, je pense, mais en tout cas qui s'associent avec des producteurs.
D'accord. Merci. Bon, d'accord. Donc, les principales conclusions du RISPO, donc je vous disais, on avait organisé cette journée du fait de l'intérêt vraiment croissant au niveau national et international. Il en est ressorti que c'était véritablement un outil d'atténuation du changement climatique, puisqu'on est quand même sur 1 tonne de biochar pour stocker 2 à 3 tonnes de CO2. Un process de production qui a 2 variables principales à maîtriser, la température de pyrolyse et la biomasse utilisée, ce qui a fait dire à plusieurs intervenants qu'il n'y avait pas un, mais une foultitude de biochar. L'importance d'une ACV positive, donc c'était une des conclusions des principales recherches qui nous ont été présentées, et des utilisations qui pouvaient être aussi hors sol. Bon, je vous apprends rien, hein, on était vraiment sur une conférence pour nous. Et donc, avec par contre, là du coup, un retour au sol principalement sous forme d'amendement, mais avec une alarme sur la qualité de ces biochars et sur les apports qu'ils pourraient avoir ou ne pas avoir, voire des effets négatifs. Donc, vraiment, une grosse attente de la part des membres du RISPO sur les résultats des études qui ont été présentées, mais qui sont encore en cours. Et donc, voilà, c'est ce qu'on a pu en sortir. Ouais, merci.
Merci Gaël, merci Jacques et Hervé, effectivement, qui en fait un petit peu... qui ont retracé l'histoire de la dynamique du biochar cette année en France. Donc aujourd'hui, on voulait juste conclure ce salon Bio 360 et cette très belle séquence sur la thématique biochar en vous disant qu'effectivement, il y aura encore de la continuité, il y aura des travaux en France qui vont être un peu plus dynamiques cette année et que ça va se faire au niveau national, au niveau de l'AT2E, l'Association technique pour l'énergie et l'environnement, notamment le club pyrogazéification. Avant d'aller d'aller plus loin, juste quelques mots. Donc, pourquoi un groupe de travail national? Donc, effectivement, il faut avoir en tête que l'association AILE et B2E ont essayé de travailler sur le sujet Biochar depuis 2016, qui a eu quand même le partenariat et le programme Trici, où ils étaient vraiment très, très engagés, qu'ils arrivent à la fin de ce programme Trici, et derrière la filière, donc les producteurs, les acteurs sont toujours preneurs de travaux, et il y avait quand même beaucoup de questions qui ont été posées à la fois lors des assises Biochar, dont j'ai eu l'occasion de participer à la fois pour l'organisation et pour les interventions. On a eu du mal à conclure ces assises avec des travaux et avec quand même des synthèses très abouties. Et à ce moment-là, on se disait, la filière, les acteurs, pyrolyse, gazéification, c'est vrai, nous sommes les producteurs. D'ailleurs, c'est ce que vous voyez sur ce schéma. Les produits d'une technologie de pyrogazéification sont à la fois le gaz de synthèse et le biochar. Et à un moment donné, on se disait il faut qu'on travaille un petit peu sur la partie évolution réglementaire, parce qu'il y avait également l'administration qui posait beaucoup de questions et on n'arrivait pas forcément à répondre. Également donner une meilleure visibilité nationale, parce qu'effectivement les assises, c'était les premières assises nationales, il faut le dire. C'était les premières assises nationales, donc on a eu quand même une visibilité de tous les acteurs au niveau français. Et d'ailleurs, il fallait quand même faciliter le dialogue avec les administrations qui étaient déjà impliquées au sein de la filière pour d'autres sujets, et notamment il y avait le biochar sur la table, donc il fallait quand même qu'on avance sur cette thématique. Quelques mots sur le club pour ceux qui ne connaissent pas. Donc, c'est un regroupement qui existe depuis 2014, qui représente les différents acteurs de la filière, producteurs, bureaux d'études, énergéticiens, également laboratoires de recherche. Donc nous animons plusieurs groupes de travail, et justement c'est dans cette perspective qu'on s'est dit le groupe de travail Biochar peut très bien exister au sein du club, sachant qu'on était déjà membre et qu'il y avait quand même une question qui était posée sur quelle serait la continuité à ces différents travaux. Aujourd'hui, on représente également la filière au niveau international dans différentes instances. Nous sommes également la porte d'entrée avec l'administration pour les différents échanges, ce qui nous permettra également de faciliter cette continuité de travaux. Donc, quelles sont les actions du groupe de travail pour cette année? Donc, on s'est fait quelques sujets d'intérêt, quelques sujets qui commencent quand même à se lancer. Donc, il faut avoir en tête qu'il y a des travaux de normalisation ISO sur le biochar qui ont été lancés au niveau international. La France en est membre, et je remercie notre pilote de GT Biochar, Dominique, qui a également il était partie prenante, et c'est lui qui nous disait il faut qu'on y soit. Également, il faudrait travailler un petit peu notre verbatim, nos arguments, si j'ose dire, sur qu'est-ce que le biochar ou les biochars, comment est-ce qu'on peut les valoriser, et comment est-ce que la filière française peut exister demain sur cette production de biochar. On peut également travailler sur tout ce qui est guide de HSE, donc tout ce qui est bonne pratique, comment est-ce qu'on peut produire, entreposer, quelle est la logistique derrière le biochar. Donc toutes ces questions-là, on les voit quand même en abordant les porteurs de projets, en voyant tout à l'heure, il y avait des REX internationaux quand même plutôt européens sur la filière, on voyait pas mal de sujets qui revenaient souvent. Donc on essaiera également d'établir un petit guide au niveau de la filière. Et pour finir, avant de finir, je voulais vous dire quelque chose sur la proposition de normes qui est en cours. Je pense que les slides n'étaient pas bien intégrés, mais c'est pas grave. Du coup, voilà, aujourd'hui, il faut juste dire quelques mots. Donc, la décision de travailler sur cette norme date du mois de mai. C'est le pays qui est quand même pilote de ces travaux de normalisation, et le Canada. Il y a 14 pays membres. La France y est partie prenante. Vous avez quand même quelques acteurs français qui sont dedans. Aujourd'hui, il y a des travaux, vous connaissez peut-être tous tout ce qui a été fait à l'EBC, à l'EBI, à l'IBI, mais effectivement, ça change assez fréquemment de ce que j'ai compris, d'où la nécessité d'avoir quand même des classifications très très claires, à la fois pour aider le producteur et aider également le consommateur derrière de ce biochar. Aujourd'hui, juste pour vous dire, il y a plusieurs étapes pour définir une norme, et aujourd'hui nous sommes plutôt à l'étape 2 qui est la proposition de ce premier projet de norme. Derrière, il y aura encore d'autres étapes, et c'est bien qu'on puisse aborder ce sujet-là au sein de la filière, et que ça soit également porté par un regroupement au niveau national. Pour finir, quelques mots sur le GT. Donc aujourd'hui, nous avons 30 inscrits, à la fois des producteurs, des bureaux d'études, et également les regroupements associatifs, comme l'association AILE et B2E. Donc le lancement du GT a été fait en ce mois de janvier, sachant que derrière, effectivement, avant octobre, novembre, décembre, on a également travaillé ensemble et c'est comme ça qu'on a eu la journée technique avec le RISPO qui était également un événement pour clôturer l'année et pour faire l'état des lieux de ce qui restait quand même à travailler. Aujourd'hui, si vous voulez nous rejoindre, vous êtes les bienvenus. Bien sûr, vous avez mon contact et le contact du pilote du GT qui est également avec nous. Et on vous dit à très bientôt. Voilà, la France contribue également à ces travaux de biochar et on espère être quand même partie prenante pour tout ce qui se passe au niveau international. Et j'arrive à la fin de cette présentation et je vous remercie et je remercie également mes collègues pour cette prise de parole.
C'est conclu. Ah bon, non.
On est d'accord. C'est la fin.